Thank you. Malin, confirm you can see my screen and I'm audible?
Yes, you are, and I can see your screen.
Okay, awesome. So thank you, team. Thank you, community, for joining the session today. So today we'll be discussing one of the components in software engineering that is very important. That is software architecture, or rather, how do you begin building a product, and how do you go about, especially from a developer to architect front. So usually, you will start, let's say, with the empathy mapping or the design thinking, but then we are looking here. So you have the use cases, you have the journeys built. So as a solution architect or as a developer, how do you go about looking at it? So pretty much that is the scope. To introduce myself, I'm David Kazi. I'm a software engineering manager at Safaricom. I've worked as a solution architect, enterprise architect for the last 9 years. So some of the components, some of these discussions we'll have today, most of them I'll speak from experience. Some of them will speak from what systems that have happened. So I'm tailoring the discussion today more like, first of all, we are introducing what is software architecture, the different architecture models that are available, and how to go about, especially looking at the current industry or technology industry, what is available for the developers. So today we'll do a lot of the discussions, largely looking at a theory perspective. We'll discuss one of the use cases that we are going to do a live design session, where we'll go through a live designing sprint, where, for example, what the scope of that design session is going to cover. From the use case that we'll discuss today, we're going to develop the vision for the product, the technology components, looking at the design constraints that are available at end to end. So feel free to put the comments on chat so that we can answer them. I'll want to begin with the discussion. So bear with me. I'll put off my video so that we can have smooth communication on the webinar. So, like I've highlighted, today's goal, we are going to look at. So I've broken it into three contexts. So we look at the fundamentals, basically looking at today we have software being developed across the business or the landscape that are available. Some complex, some simple. Most of them are going to be developed using methodologies that are modern. That is methodologies that are cloud native, because that is where the industry is going to. So we're going to look at the fundamentals, basically building from a history, where we are coming from and where we need to go into. We look at some of the architectures that we will be looking at in terms of building. We'll look at the various components that you can build in software architecture, looking at the different architecture types that we need to work on. So today, that will be what we'll discuss, the fundamentals. Going into next week, we'll actually do the live implementation, where we'll implement the use case that we'll discuss today. We'll do a tailored architecture that will target to implement using Java, that is Spring Boot. We'll also target to implement the architecture as cloud native. Basically, you should be able to host or deploy the solution in any containerized environment, cloud agnostic. And then at the same time, today when you're hosting your applications, when you're serving the customer, you need to look at what are the features, what are the security features, what are the monitoring features that you need to make available, so that you can ensure that your services are always available, always on. You have full visibility of the customer interactions. So we'll tailor that that's how we'll tailor the conversations in this work stream, or in this session that we are doing on design-driven architecture. So I know a lot of questions will come in. So people will ask, what is architecture? People will ask, what is software architecture, and which are the various architecture types? So when you come to the industry, in the industry, you will notice that you will have different terms or different architectures asked by different domains. So you could find in our infrastructure area, where people are discussing stuff related to hardware, storage, and communication infrastructure, people will ask you about the infrastructure architecture. So how do you communicate about that same? Because that forms part of the architecture. If you go to other domains, you'll be asked about the security architecture. So how have you thought about your application, how you're building it or how you're deploying it from a security architecture? There is technical, the solution. Basically, what are the various components that you have for your architecture? Looking at what is the implementation methodologies or frameworks that is available for that. Look, it could be looking at the technologies, that the development languages that you have. It could be looking at the web servers, the application servers, and the database servers. So there are various types that you look at in terms of looking at architecture, but we'll want to speak from a software architecture, whereby from some software architecture, I'm looking at this application and being able to decompose it into the respective modules that I'm able to build. And that particular module or that particular component could be, it should be technology agnostic. I should be able to build that component without needing to care which is the implementation language I'm using or where I'm going to deploy the solution. And when you look at the entire now application in the industry, where a particular feature or a particular business case needs to be delivered using multiple application components. So for example, if you look at our e-commerce, if you look at an e-commerce solution like let's say Jumia, you find there is a customer facing module. We could call it, let's say, the customer engine, customer management. There's the order processing engine, we can call it the order management engine, and then we can have, let's say, something like an notification engine. So looking at the specific components, you could design each of the components separately. We call them those are the application architecture. So I have the customer management application. You design it separately, that can easily be built separately by a team or even using a technology. But then when you combine all of them and how they're interacting with each other, then you now formulate now the system architecture. You look at Jumia as a whole ecosystem. So our goal today is to speak when you're building your software, when you are building your application or you are serving a particular business needs, what is it that you need to look at so that you can be able to serve the specific use cases. So here we are going to look at, in the architecture, we are going to look at items relating to how are you able to trace a particular issue that let's say a customer has raised a complaint on, or how are we able to come out of an incident that has happened. So here we are going to look at items related to logging. How do you handle logging from a software architecture perspective, and how do you implement it? We're going to look at how do you secure your solution. There are various ways that you can secure a solution. We look at the various, we look at things related to authentication, things related to encryption, things related to tunneling, and also things related to GDPR, because remember, this solution, you're going to host it on cloud. So how do we ensure that we secure the information that we have for our customers? There are other things that we look for architecture related to performance and scalability. Remember, we are going to serve various customers. We're going to serve millions of customers in this case. So for example, we've said we're going to build a in our use case, I shouldn't have mentioned in the first set, we are looking at maybe building a travel app. A travel app where various users across the globe should be able to, let's say, visit Kenya and should be able to get all the details about the various site destinations and get the various packages that are available. So you need to ensure that the architecture is able to be resilient enough and serve the customers without having any problems. Things related to regulatory, I've mentioned that one because of cloud, GDPR rules, and also looking at the real world constraints. The real world constraints we're looking at, for example, is we need to ensure that our system is fault tolerant. So today you have a data center that you've hosted your application. What happens in the event that something has happened? So we need to look at having the solution being fault resilient, having the solution being able to be up and running, even in the case that you have instability in some of the components that are running the system. Our software needs to evolve. Our software needs to always grow. It needs to adapt to new changes. So how do we ensure that our system can easily be adaptable? We can easily have it integrated to other components, other systems that are available, assuming we need to build an integration module from our travel app for payments. So we need to be able to have our system ready for that capability. So those are the things that we need to work on. Operational and support, I've mentioned we need to do logging, we need to do exception handling. So how do we ensure that we can even generate a dashboard from these logs that we're generating, and we're able to maintain health checks of our services that we can we can maintain available, so that we can see the visibility of our system performance. So these are the components that we're going to look at, and what we need to achieve at the end of this. So that becomes the key big picture that we need to handle in our software, in our architecture. So when you're looking at an architecture, who are your target audience? So usually when you're looking at an architecture, we have various audiences that are going to use your architecture. In this context, we are looking at the developers. So developer to developer, developer to architect, you've designed your system. How is the developer going to interpret the design that you've provided? Is it making meaning to them? Is it creating alignment with them? Is it something that is consistent such that one developer to another developer, they're able to interpret, they're able to implement? So those are the things that we need to address in our architecture. We need to look at the architect to architect. If I'm passing this solution to an architect, assuming this solution is going to be implemented in another geography, in another industry, it should be able to be replicated. It should be able to be understood by the architects, the product managers, and the product owners. Remember, when you're looking at the architecture, in the modern day, we do the agile architecture, where we are able to define even how do you want to implement your solution, so that you are able to have milestones. You are able to decompose your solution such that you have milestones, you have deliverables that are easily trackable by your project managers. Remember, at the end of the day, the architecture is supposed to give to address constraints that we have in architecture, that is time and money. So we need to look at how can architecture speak to our project managers in terms of planning and in terms of releasing to the customer, so that we can have value to our customer. So in a nutshell, you look at providing a bird's eye view, one, to the product managers and even the sponsors, so that they're able to understand the solution end to end, and even they can plan communication to the customers. Two, developing a lingo where we are able to share with the other developers, share with other architects, so that we can collaborate in the architecture, so that we can build a seamless view with the rest of the team. Then we are also going to look at the architecture is going to guide in the technology choices. So today we've said we're going to do our solution, our use case, we're going to implement as a cloud native solution. So the technology choices that you're going to make there, the architecture that you're going to speak about is going to address that. Is going to speak, why did we choose a particular database vis-a-vis another one? Why did you choose to implement, let's say, with a particular service, let's say caching solution that is available vis-a-vis another? So those are the technological decisions that we need to come on, or the design decisions that we need to bring about. In terms of the roles, it will help in terms of if you're having different teams, if you're having different if you decompose your services or your application, you're having different teams, you should be able to clearly depict what a particular individual, what a particular person, what a particular engineer or architect is able to address. Could be let's say it's a solution that you need to work, it needs to do with database. Assuming you are in an environment where you have database engineers, or you are in an enterprise environment where you have different matrices, where application developer will only handle application, infrastructure engineer will only handle infrastructure, things related to that databases and storage. So it clearly demarcates who is responsible for what particular solution. So that is what we are looking at in terms of the architecture. And we are saying architecture is a very important aspect in software engineering, because at the end of the day, you need to look at the end-to-end implementation of software, looking at the physical, looking at the logical, network, and everything. Physical, we are looking at how do you need the switches, especially, for example, when you in some organizations, they still do on-prem development, that is on-premise services. So your architecture needs to speak, how do they lay out their deployment architecture, how do they lay out their various physical servers, and provide that information. When you're doing architecture modeling, so how do you do architecture? How do we communicate architecture? Remember, we've said you need to communicate to the various target audiences. So how will a business person, how will a project manager, how will another developer understand your solution? So ideally, we usually have an agreed, we can call it semantic, where we usually put our thoughts, or we usually put our big picture of the solution in in a pictorial representation. Basically, you have some components that components in the system that are depicted as boxes. I'll show it in the next slides. And we have now relationships between the various systems or the various components depicted as lines. So usually also to separate the different ecosystems. So for example, I've mentioned about the infrastructure team and the application development team. So sometimes you need to demarcate which are the application components, which are the database components. So usually create the layers, and also the users of the system, they're usually treated as the actors. So we look at a naive kind of implementation of an architecture. So if you look at this diagram, it basically depicts how what I've mentioned, how an architecture is. So basically you look at an actor becoming the user, and you're able to say, for this particular travel app solution, I need to be able to do my packaging as an administrator. I need to be able to target the packages to a specific customers. And me as a common user or customer, I need to be able to select the solution, a particular component. You are able to demarcate the layers. So you have software component 1, component 2, component 3. So if you look at this simplistic idea, yes, it provides a simplistic view of an architecture, or what you need to do, or how the system is built, but it doesn't give you, or it doesn't communicate to a developer in a contextual way what it is that they need to work on, or it doesn't communicate to another consumer, let's say an infrastructure architect or an infrastructure engineer, what it is that they need to work on. So that's why we need to go further and do some decomposing. And that's why we have some of the common architectures that we have here that I'll speak to, because they run in the enterprise today. So when you're looking at architecture today, if you work in the enterprise environment and even in the SMEs, you'll notice that you'll need to have various components of your application that you need to work on. So today we are going to build, let's say, the travel app. So you're looking at the app being a mobile application that is available. So in terms of depicting the software components, so you look at it that it will have, let's say, a backend system that integrates, let's say, to a CRM, because I need to know who has logged into, who is accessing the services. This is especially for those registered customers. It will need to talk to the database, assuming there's their orders or their payments, that payment transactions that have happened that we need to talk to. In enterprise organization, you notice that there are some legacy systems. By legacy systems, we mean these are some of the core systems that have been built many years ago that that run the core functions of the business. So, for example, looking at in the banking industry, they usually have something we call the core banking system, which has all the accounts, which has all the banking transactions and the rest. So that becomes like the legacy system that you need to integrate. Then you have now your mobile application needs to talk to the backend system and the legacy system. So usually we have an abstraction, a component that you can call the API server. So from a software component architecture, it defines the different modules or the different components and how they interact. And even when you're looking at the interaction, it also specifies how you want to interact with a particular component that you have it. So it could be a REST API, it could be a SOAP API, it could be a TCP connection for socket connection. So those are the specifics that you need to cover when you're having the component architecture. So another level of architecture is, so when you decompose further, you need to, this is for depicting or explaining, now building on the previous architecture. This now when you're explaining how your components are accessing and from which location. So you build up the network architecture, which speaks from which IP, from which ports, or from which environments are your application made available. So you have applications that are sitting, let's say, on the DMZ. These are the applications that are in the demilitarized zone. Basically, these applications are sitting on the public facing. They are accessible on the internet. And then you have your core applications which are sitting on the internet, which are supposed to be secure. So that if the event, let's say, the reason why you do segregation is in the event an attacker wants to access your backend, they have to go through multiple layers that have security that have been put in place so that they are accessing the internal services. So, for example, So if you come here, the mobile application has been enabled to talk to, let's say, the internal load balancer on a specific IP and port, and there are firewall rules that have been applied here so that we are able to secure the internal connectivity of the internal services. At the same time, when you look at the DMZ, we have here routing that has been put here from a network perspective, such that not all IPs, internal IPs, have been exposed on the public subnet or the public zone, so that we are able to secure our backend system and an hacker cannot be able to have access to it. At the same time, if you look at it also, we also have our database only being accessed by the backend at specific IPs and ports, which has been secured. If you look at in enterprise organization, there's usually also another layer here where these applications are segregated using networking components that we call subnets, so that there are specific firewall rules or there's a specific network filtering rules that have been applied so that we can secure the various environments. So that's how you look at from a network architecture, and it helps in terms of communicating how your solution is going to meet the security needs that are available, and also how the network team are able to secure the environment. Okay, now in most organizations, especially the enterprise, you would notice that for the on-prem solutions, they would want to have specific infrastructure where they are deploying their solutions. These are the physical infrastructure that they set up in their data center. A data center is basically a cold environment where you have all your massive machines or massive servers that have been put in place that can run your application servers, or that can run your servers to host both the business engines or the business applications and the database instances. We usually have multiple data centers. This is to ensure that we have redundancy. So when you're looking at your software architecture, or when you're looking at your architecture end to end, for on-prem solution, you need to provide this kind of architecture where you're actually explaining how, on a physical layer, how your systems or the physical nodes have been hosted. Sometimes, if you go to some enterprise application, even to a networking layer, this firewall, it's able to be configured such that only this particular load balancer can talk to a particular data center. So to some detail in some of the architectures, especially for enterprise or even for some of these big business organization, it is important that you document that information such that whoever is supporting the solution, assuming let's say one rack is down, we should be able to identify from which particular point of failure did that particular error or the service degradation occur. So that is how we handle the physical architecture. Okay, now this is now going into the modern implementation approaches, where we are saying we want to leverage on what services are available on cloud with the various cloud providers. Today we have different cloud providers who give us cloud solutions. Basically, you are able to run the whatever we did on prem as services on cloud. Could be storage. Storage is automatically available on demand. So however you want to use it, it's made available to you. Could be VMs. This is we call them the instances that are available on cloud. You should be able to on demand be able to have the instances. The instances are already available for you as when we say on demand, they're able to scale at any speed or whenever we have traffic up and down. So those are the auto scaling that we are looking at. At the same time, you have if you look at the previous architecture, we were saying we are setting the data centers ourselves. We have the physical racks. When you go to cloud, you don't care about these physical data centers, because all that has been abstracted to us as the consumers or the users, and all we are given from the data center perspective is an availability zone. So if you look at availability zones, it's pretty much the physical, or we can call it in layman, they are the physical data centers that are available for the cloud users on the cloud environments. So you have, for example, in this case, I'm projecting the AWS simple architecture, where the availability zone could be, it's one of the data centers that has multiple servers, multiple racks that is available. For us as consumers, we don't need to care of. So when we go to cloud, we only care about deploying our solutions and getting the specific services. It could be, I want to have my services running on containers. So you notice that for cloud, they'll provide for you the Kubernetes services or Kubernetes as a service. So For AWS, they'll give you the EKS or the ECS, where you're able to run your services, that is container services. For Azure, they'll give you the Azure Kubernetes services, and also for Google, they'll give you the Google Kubernetes services. So that is how we'll look at deploying the solution, or we'll look at deploying the services. When you look at the infrastructure, there we've already been provisioned with managed services that is available. So when you're speaking on your cloud architecture, or when you're speaking on your software architecture, you need to look at, when you're building your application, you need to look at what are the services that you're going to consume on cloud. So it means, for example, if your application, you're going to design it to use, let's say, database that is relational, we have managed services that are already available, like for example, Amazon RTS, that your application is going to consume. If you need to do document, we already have NoSQL. We already have document databases that are available for the cloud consumer. So when you are speaking your architecture, or when you're defining your architecture view, that you have to explain, or you have to provide that information that any cloud architect or cloud engineer is able to deploy. At the same time, when you're looking at the cloud, there are security elements that you need to handle. There are networking elements that you need to handle. So you need to speak, or you need to communicate how you're going to handle load balancing on cloud. So there are also services that are available for cloud to do load balancing. For security, we also have the firewall solutions that are already free on cloud. And also for DNS, we already have solutions that are available. So pretty much we are looking at having the solutions available for us so that we can consume. So in our implementation, what we are going to do is we are going to implement a service-based architecture, where basically we are going to build a microservice kind of architecture. The reason we want to do this is if you notice, for us, when you're going to cloud, we need to look at how do we scale our microservices, or how do we leverage, or how do we leverage based on the cloud services that are available. Today, the cloud services, we have the already containerized environment, or the container orchestration environment that is available for us, and us building the microservices it's an easier big win for us. Had we to go to monolith, then it means we need to look at what are the services available or made available to us that will allow us to deploy the service on cloud. So for example, if you go to AWS, they will say if you have a monolith application, instead of containerizing it, you can utilize services for like Elastic Beanstalk. So that is how so we are not going to look at this implementation, but when you are actually doing the deployment on, assuming you are doing an architecture for on-prem for a legacy solution, then you'll need to do this consideration when you're actually migrating to cloud, or when you're actually deploying on cloud and on-premise environment. Okay, so how will we evaluate, or how will we look at our architecture? Okay, so we'll ask ourselves, are we following some guidelines? Are we following some structure in exposing our design? Are we utilizing the right components? Let's say, assuming we're doing UML, are we utilizing the right UML components in communicating? Are we doing it consistently? Like we mentioned, we're going to do microservices. So are we doing the designs consistently such that it's easy to understand? I'm in this particular context. I'm in a payment context. I'm in a customer context in such a way. So it's very good that it's very good that we communicate well in our architecture, so that because it will give us the big picture of the solution. Okay. Also, when you're building architecture, it becomes easy. So we need to understand. We need to look at it. Does it give us quality in terms of our code base? So assuming, let's say, in my design, I've put data models that are inconsistent with what has been implemented in the code base, then it means my architecture, if it is evaluated, it means it's not right. So in my design, the customer model is different from the actual modules or the entities that have been implemented in the database. So we also need to address such things, so that we are able to communicate clearly how our design is. Of course, I mentioned the shared vision, so that we can do collaboration, and also have the team have some guidance. So for example, if I'm going to do caching so that I'm able to easily get the frequently searched locations or packages that customers have been asking, then it needs to be easy to communicate from a design front. And also some of the technical leadership we need to address is, for me to choose a particular caching strategy, then it needs to communicate why in your design you chose that particular caching strategy. So whoever is implementing the solution, they are able to look at it. So in a nutshell, it means we'll have a clear vision, we'll have a better coordination in our architecture, we'll have the architecture answering all the questions for a developer and for an architect relating to the frameworks and the implementations they have. So what is it that we are going to build? What is it that we are going to architect? Okay, so in our next implementation, the hands-on, what we are going to do is we are going to build an application. It's a fictitious application that we are saying, we're calling it the travel app. Basically, it will have two users. That is a common user and an admin. Basically, for the common users, they should be able to search which are the travel applications. So we are calling it a hospitality travel app that will address, let's say, Mombasa. I want to visit Mombasa in Mombasa city. Which are the locations available? Which are the packages available? So, like in an itinerary, I need to go to, let's say, a particular sightseeing environment, and what is the sequence of activities or events that I need to follow through. And then we'll have the administrators who will be doing the packaging or managing the packages, and they're also doing the costing so that the various users can use. So for that, it would mean our goal in our architecture, we will be explaining this, and this is how we do it. For example, in the industry setup, we will explain the overview of the application. That is the architecture we are building, the vision. We look at the various in the vision. We'll also break down what is it that we want to achieve. Okay, the goals, long-term business, and the competition. So we'll try to explain that, because if it is missing from the architecture front, then it will miss in terms of explaining in terms of how do you evolve the application in future. If requirements are changing, are you aligning it to the goal? Are you aligning it to the mission? So it clearly needs to speak to that. It needs to speak to the specific use cases that are being implemented. So we'll also look at that and decompose our solution in that. It will need to address a number of cross-cutting concerns, like I mentioned in the first slide, the second slide. How do we discover the specific services? How do we apply modern, mature automation in terms of deploying the solutions? How do we easily extend the platform availability, scalability? So these are the cross-cutting concerns that we'll be looking at. So in a nutshell, if you look at it, we'll address all the specific journeys in the design, which are the specific actors, which are the specific functions they need to do in the system. We'll do the developer to developer discussion, which are the specific class models, which are the specific let's say for functions or attributes that will be implemented, especially the core ones, and we'll also provide the interaction that needs to happen in the system. Of course, if we have time, we'll also specify the database model that will also address the context module. So if you look at it from the interface perspective, yes, we could easily implement using the from a web front, but for us it's an app. It's technology agnostic. We should be able to implement in any technology. So of course we'll build APIs. So we'll build our application as an API. It will be API oriented as microservices with different modules. The different modules, like I've mentioned, we'll have the customer, that is the consumer module. We'll have the admin module, and if we have time, we'll also have, let's say, a payment module. When the customer selected a particular package, how do they pay? Of course, we'll track all the activities in the database. We'll try to utilize as much as possible if we can do NoSQL and SQL, because there's, for example, if we have reviews that are happening for a particular package, we should be able to have those reviews captured in a NoSQL environment. So we'll provide in our design, we should be able to handle that when you're actually doing the actual design. In terms, like I mentioned, out of implementation, we can use any technology, but our focus in building the services, the business services, we are targeting to do a Spring Boot. So in the what we'll do is if we have time, we'll do the actual implementation. But I think for today and the next session will only focus on the design, but to test the design, we would want to implement. So I was discussing with the organizers of the webinar if we can have some of the developers work to implement. So preferably we'll do Spring Boot, and we'll have this one on GitHub and share with the rest of the team for view. So those are what we'll implement. We'll handle, like I've mentioned in all these concepts on the diagrams, we'll handle the general architecture, schema, caching strategy, and also the deployment strategy from a cloud native front. I mentioned we should be able to speak on the milestones. So we should be able, if we were asked by a project manager or product manager, how are we going to do this? We should be able to depict or do these kind of milestones from. So we'll be able to generate a tentative, or we can call it like a work breakdown, how we want to do our implementation, and maybe even track it from a release perspective, what we should be able to release at a particular go. Of course, in our architecture decisions, of course, we've chosen to do cloud hosting. We'll provide our reasons why. Our mobile platform, if it's from a design perspective, you need to actually provide the implementation, because today there are various frameworks that you can choose to implement your mobile. You can choose Firebase, you can choose Android, you can choose iOS. So it's very important that you explain your architecture design decisions or records, provide why you chose that particular solution. So in our design, we'll also have this one as a design decision that we had. Also explain why you chose Spring Boot, and also I've put this one as italics. If we have time, we should be able to also provide this in the system. So pretty much in a nutshell, if you look at the design, what I've explained, in our design, we need to explain on the context. So you need to explain to the different users how your system is going to look at. So in the context is, if I'm a business person, what is it that I need to see from a context perspective, the capabilities that are available? If I'm a technology person, which are the technology components that I need to, assuming I'm a DevSecOps engineer, which are the services that I need to deploy on cloud? If I'm a database engineer, which are the database that you need to handle? So pretty much from a developer perspective, you can look at the containers. How are they going to structure their services? How are they going to decompose their services? And how are the components going to speak to each other? That will also address the classes that they are going to be developed. So all this is what we need to address in our design. So pretty much that is the theory bit of our design process on how we are going to implement it. So like I've mentioned, in the next session, in the next webinar, we are going to do actual implementation. That is to design the end-to-end of the travel app as a practical session with the team, and then run a mock-up on Spring Boot. Pretty much, Kamochu, that is it. Malin, thank you.
Thank you so much, David. Oh, yes, Malin, I'm just handing over to you briefly, but I just wanted to say thank you very much, Bona David. This is truly a master class. At least it gives a very good picture of everything that I have experienced. And I have also learned a few things from here. And I'm also quite excited to hear that you want to show us how to actually do this, because that's the most important thing. So Marlene, I hand it over to you, because you're the one who had welcomed our guests. So I don't want to be that guy. So over to you, Marlene.
Kamuchi, you can be that guy, but yeah, thanks. So thank
you. Are you saying I'm that guy?
No, I will keep my words.
Thank you.
So thank you, David, for that session. I have personally learned a lot about software architecture, and I hope our audience also has. And if anyone has a question from the audience, yes, would be a good time to maybe ask Mr. David any questions that you have, if you're thinking of going into that line of tech. Yes, he's also available. to answer your questions. Is there anyone in the audience with a question?
As long as they don't ask for the sample code in this phase.
Yeah. So what we'll do is, I think maybe today we did it from an enterprise perspective, because I was speaking more from what happens in the industry. So for example, when I was speaking about the various component architecture, so in theory, yes, we usually you usually describe the architecture, you say this component A, component B, component Z. But then when you come to the industry, those components need to speak to each other. Those components need to speak exactly what it is they are doing. And those components need to speak to the various audiences. So assuming, for example, today we are saying we are going to have 3 components. So there is an admin component, there's a customer component, and there's let's say the newsletter component. Each of them needs to speak to the various users. So you as me as David Kazi, as an engineer, need to understand this component is going to be addressing ABCD. Then when and as a business person, assuming I'm the sponsor for the travel app, I need to understand that the big picture of this solution, from if David Kazi has understood it, it's going to address this particular pain point. Customers will be able to access the services. It's going to address the newsletter. Customer is going to have the newsletters. It's going to address the recommendations. Customer is going to have that. It's going to address the administrator easily being able to configure the services. That's how we are looking at it from a component architecture bit. But then you go another level layer where you actually explain from an implementation perspective, how do you deploy the various components, or how from a technical front, how do you deploy the various services so that it's made available. That's when you start talking about the technology architecture, looking at the infrastructure. So I'm going to deploy the solution, let's say on cloud, or I'm going to deploy the solution, let's say on a particular VM that is provided for me, or I'm going to deploy the solution on a particular physical machine that is available. So it becomes important for you to have that information provided in your architecture, because if you come to an organization, there are various levels. Assuming, let's say we are deploying it in an organization on physical machines, we have 101, we have, let's say, 5 machines. Okay, if you don't provide that information, like this is machine A, it's for this application, it has this IP, it's exposed at this port, anybody can easily come and swap the machines and you never know. So it's very good that you document in your architecture, these are the machines I'm using. If it's an enterprise environment where it's virtualized, you're able to explain this virtual machine A, B, C, D, this is what the services, this is what my services are running in. And if somebody needs to access it, maybe for maintenance and operation, you also need to provide the security, how they're going to access and the rest. Coming to network, in the enterprise, the network, if you go, let's say, to an organization, they need to talk to internet. So assuming you are in a banking industry, the bank has internal applications and it has the business partners. One of the business partners could be Safaricom, for example. How do they exchange messages? Let's say for M-Pesa, it's very important that you provide that level of network architecture clearly, so that any person maintaining the system, they're able to address. If somebody, for example, if we had an incident, for example, an incident that could occur, where, let's say there's a vulnerability on a particular server, when you have it documented, when you have architecture explained clearly, providing that where that server is, it's easy then for anybody to come and mitigate that particular solution. That's why it serves a purpose where it's cost efficient. You are easily able to manage the service, the ecosystem, and also it's able to create the visibility end to end. So there's a lot also on cloud. It's so much detail on cloud and very easy also to implement. Thank you.
Thank you. Thank you for that explanation. So if this was software architecture from the enterprise side, what is the other side?
Oh, when you come to, and this one I usually recommend for startups, for example, when you come to the startup environment, I usually recommend to go the cloud native deployment architecture, because with cloud native, for a startup, you really don't have okay, yes, you have your customers, you are getting into the market, you're getting into the environment. So I have this solution. I don't in my roadmap, I am targeting, let's say, 10,000 users, right? assuming we are targeting, let's say we deploy our app, we are targeting the Kenyan market. We notice that we have traction, then we start expanding it, let's say to East Africa. You target a bigger market. So let's say we target now 50,000. Then we go now to, let's say, East and Central Africa, start doing 100,000 and the rest. So with cloud, it gives you the ease. One, you don't need to start investing in getting the servers or setting up the servers internally. Everything is already available on cloud, and you can even test the solution. You can even start from cost zero, because if cloud gives you even the free tier from a startup perspective, assuming you are very lean. But the more you expand, you can now start leveraging on the on-demand, the scaling, where automatically you can have different instances provided for you so that you're able to match the services that are available. Cloud, you don't need to start spending on stuff, for example, like firewall. Firewall is usually an expensive solution for on-prem solution, or when you're deploying your own infrastructure. But then when you go to cloud, it's provided for you as a service free. So it's easy for you to secure your services from cloud. And with cloud, you have different architectures. So you can choose to deploy it as a monolith architecture. You can choose to deploy it as microservices. You can choose to deploy it as, if you can choose to run it even on an EC2 instances or a specific instances that is available for you. So there's flexibility, a lot of flexibility that you have for cloud. That is the other side, largely for startups. For enterprise, they have started noticing that there's a lot of benefit in terms of investment in cloud. That's why big organizations today are trying to migrate their services from on-prem to cloud, because so for big organizations, you're looking at, do you invest millions of money in setting up an infrastructure on-prem, or do you invest on a particular budget, let's say 20 million, that you would want to run your services on demand? Because you see on-prem, assuming I want to do 1 terabyte of storage, because that's my projection for this year in my business, that is on-prem. It means then I have to have a fixed cost, right? But when I'm going to cloud, I don't need to automatically set that I want 1 terabyte of storage. I can just go there and utilize what it is that I have. Assuming I have 50 GB, that's what I need to use. So as it grows, that's you start paying for what grows. So you haven't spent on the extras that is available. So that's why it's really good that you go the other side. Yes, Marlin.
Okay.
Yeah.
Yeah.
Maybe Marlin, I wanted to maybe add one more question. I've seen, because you brought up the topic of startups and enterprise development. I've also seen a lot of conversations around how now do you put the boundary of your services, considering also that context. Because I've seen there are guys who really do, and having worked with some enterprises that are doing cloud native applications, you find some people who have really high level nature of the service is it's too micro sometimes, because you'll find a guy creating an API as a service. And if you want to add a suspend or create an account, that's a service. If you want to query an account, that's a different service. And I've always battled with, what's the difference in terms of the boundaries for our services? If you go to enterprise, where there is a lot of people working on the project, and you also go to startups that probably don't managing 10 or 15 services to offer one major service to the customer is an overkill. So I don't know what your experience has been regarding that, but I would like to hear your thoughts on the same.
Okay, so yes, Kamochu, like you've clearly put it, we usually have that problem. So for example, if I can just project my screen, like you've mentioned, assuming today we are building, let's say, a catalog API. Okay, so you find an organization or an engineer can decide to build, let's say, like you've mentioned, update the basic CRUD that we usually do. Yet delete, something like that.
Yeah.
And then you find in another organization, somebody will say catalog update as an API, catalog delete, something like that. So
Yes.
usually in an enterprise, we would want to, you see we have different teams working in a particular product. So for example, we have a team that is working on a catalog solution, or the catalog module. So you would want to lump the features that are related on the catalog as one service. So you didn't want to decompose. But then it reaches a time when you are doing your decomposition, you notice that even that catalog API, the one API that you've built, when you're trying to maintain it, it becomes like too massive. Then mostly a clear use case would be like an order management system. Okay, because an order management system, you would have, let's say, a consumer order management platform, or assuming this consumer order management platform on enterprise order management platform. The consumer one handles different kind of orders, or handle this different kind of products. The other one for enterprise handles a different kind of product. So for that particular case, it's easy for you to separate. But you come to other organizations, the order management process, the custom is the same, the processes are the same. So you want to loop them together. So I'm looking at it. It also depends on the specific use case, or it depends on the specific requirement that is there in that particular instance. But ideally, my approach would be, it would be good to build a service-based architectures. So when I look at service-based architecture, I don't want you to decompose a service too granular. Like you are building, let's say, catalog update, catalog delete. No, just build service-based, where you, if anything related to a catalog management, build it as a service. Anything related to order, build it as an order service. Anything related to customer, build it as a customer service. Don't decompose too much. That's how I'll look at it from experience.
And even this applies for, and I'm assuming behind the scenes, they might not even share the DB.
Yes, they don't share the DB.
They don't share the DB.
Yes.
So
yes.
My biggest struggle has been, especially working with the young guys who are starting. So you find now they are maintaining too many things, and you just need to do like a basic prototype. Is there a cost to just having? Because there is a guy who wants to create a basic system with only 5 objects, or sort of, if you want to think of in relational language, 5 tables. And then you find the guy now creating 5 services, maybe for customers, patients, and all that. Then it becomes quite a serious overhead, because this guy has to manage all these things. And I don't know whether you have ever had an experience with that, or is it recommended you start like that from the beginning, from your own experience, or is there a trade-off that you can, a cost that you can bear, then you pay it later, or you create a technical debt that is worth creating and paying when the solution is actually getting to a place where you know that this thing will actually work? Then you rewrite a few things. I don't know, but I've always battled with a guy trying to do a basic thing, like maybe a registration portal. And then now they have a list of 8 or 10 services because of those boundaries that make a lot of sense if you think about it.
So when we say
it's the same developer, you know, you could say that the order management service is being done by a team X. So that makes a lot of sense to separate, especially when you have many people. But these are like 2 guys who are working on 7 services.
So in terms of productivity, it might be a challenge for you to decompose further, because you have, remember, when you're building a project, each project is handled as an independent unit. So for me, I look at that as a dependency. So it could be expensive in that front. When I'm looking at the cost, let's say at the infrastructure layer, remember when you're setting up a particular database, the database itself, the configuration that are required for that database is also a cost. Then you also add now the tables and the rest. So if you had one data, if you are assuming you're building as one service and all the tables are one, then it becomes easy in terms of the cost to the database. And also in terms of if the tables are related and you want to do cross-checking on the data, cross-checking between the information, assuming it's you want to do joins, it's easy for me to do the joins at the service level or when I'm consuming from the same database, as opposed from when I'm consuming different microservices. Because remember, the complexity that comes with microservices is that each service is hosted differently. You have to create discoverability. I need to talk to service A, I need to talk to service B. So each of the services need to know each other. At the same time, network is also, it's not like an infinite resource. It's always finite. There's bandwidth, there's chat that needs to happen between the services. Assuming now you have 10 microservices and each of them need to talk to each other, there's a lot of latencies you're creating in a network. Those are the considerations that you need to handle. So you'd rather, like, how do you can you map those services together as opposed to making them separately? And also, if I'm looking at deployability of the solution, I'll only have one pipeline if I'm going to do cloud native. But if the other case, I'm going to do multiple pipelines. The other bit is if you go cloud, when you deploy a container image, the image also has a minimum, let's say, memory footprint that needs to be allocated for it. So if you have multiple services, then it means if your instance is supposed to consume a particular memory set, it's multiplied by the number of services that you have. So there are also those trade-offs that are coming with it.
Yeah, that makes a lot of sense, and thank you so much for that. And I also saw, and you brought out the different elements to consider when you're talking about architecture, which was very good. And I think for the young people that we are working with, the greatest benefit of doing architecture, I think in my view, is even collaboration and the continuity of our products. Because you always find that when something is well designed, even hand it over to another person, it becomes very easy. And all of us collaborating even becomes much easier because one guy can work on one service while the other guy is working on another service. Then I also saw DMZ. I hope there is no one who is lost when it comes to DMZ. Which is a concept that you hear a lot when you're dealing with the enterprises. And I saw you feature it in the presentation. So I just hope that there is no one who is lost on what is this DMZ that you're talking about.
Yeah, so when for DMZ, so there is usually now, when you look at, for example, when you're accessing, let's say, your mobile banking app, so your mobile app, when it's connected to the internet, it's connecting through, let's say, Safaricom. So for it to talk, so you are sending a transaction to Bank, there has to be that communication to the provider. Then that is inherently from a networking perspective. Then the request goes to Bank. So how it goes to Bank, it's coming from the internet to Bank. So to ensure that we secure, let's say, the resources for Bank, then you set up an infrastructure, a layer that is set on the internet, but has some rules that allows you to secure traffic that is going downstream, such that it doesn't become so open anybody can access your secure systems in the backend. That's why we set up the demilitarized zone. So it's a more exposed environment to the public, but has some secure rules or secure filters that only allow specific traffic or specific, we can call it IP traffic, to go to the backend or secure internet in the bank.
Yeah, and if you have ever, because all enterprises, okay, let me not say all, but if most enterprises that we have in Kenya, whether banks or telcos, all of them have a private network. So, but if you are accessing anything over the internet, somewhere DMZ is involved. There is a service that is hosted on the DMZ because only nodes that are within that, I don't know how to call it, the network segment, can actually be seen from outside, and probably those network elements can also reach some of the inside systems, of course, with the controls, as David has mentioned. Yeah. So David, I think from my end, I'm looking forward to the actual implementation of the tour app. It would be quite interesting to see. I don't know whether one session could be sufficient, but it would be quite interesting to see even how we can take advantage of the cloud native sort of architecture, where we are, even if it's just deploying on AWS, it would be very nice for us to see you doing it, or even guiding us on how we can do it. I'm sure there is, we will always learn. Yeah.
Okay, that's okay. So there's a question from David. David Nene: do cloud technologies come with CI/CD tools? Yes. The cloud environments or the cloud providers provide you with their own tools for you to do CI/CD, that is continuous integration and deployment. So for example, for AWS, we have code deploy, we have a code pipeline that allows you to deploy your solution to the environment. Same for Azure, it has that one. I think it is Azure pipelines. So yeah, it's already there. Do you choose to use your tools explicitly? For some enterprise organizations, they usually would want to standardize their tooling. So you'd find that they would want to build their own CI/CD pipeline so that it becomes, when we say it's cloud agnostic, the tool can be able to deploy a solution on-prem. It can also be able to deploy, let's say you want to deploy a solution on AWS or on Azure, it gives you that flexibility. So for enterprise organizations, they usually do that, but for SMEs and some startups, they usually just use the native CI/CD tools provided by the cloud providers.
Hello, yes. David Nene, I hope your question has been answered well by your fellow David. So yes, thank you so much, Mr. Kazi, for the session today. I have personally learned a lot, and I am hoping that the audience has too. And we are hoping that we could have you on another session on another occasion, if you are willing to do that. And for those who would like to interact more with Mr. Kazi, I'm sure your LinkedIn is open.
Yes,
but if you have an alternative means of communication, then you could share with the guys here, and they will probably reach you through that. But yes, otherwise, we are very happy to have you today, and thank you for having this session with us. I'm sure it has been a fruitful masterclass. And if there is nobody else with a question from the audience or a comment, I think we can close the session here. And yes, we are looking forward to having you in another session. Thank you very much.